Okay, so we have some practice sheet using these bar graphs, and I'm going to do the first couple for you, and then you can do the rest, or at least try to do the rest, and you can ask me for help if you need it. So let's see here. It gives you some instructions, but I'm just going to work through it. So it says here in the situation below, a spring launcher launches a roller coaster from rest on a frictionless track into the vertical loop. So this cart's going to go and down here. And we want to analyze it thinking of position A or time A and position B or time B. Okay, so let's first of all be really clear what's in our system. We have, and the questions tell us, we have the cart, the earth, track, and spring. Okay, so position A, I'm gonna call this the baseline for EG. Okay, so it's not moving, so there's no EK. It's at the baseline, so there's no EG, but it's being held against that spring, and there's a whole bunch of spring energy. So I'm going to say there's 1, 2, 3, 4, 5 bars of elastic energy. Now, I don't really know how much elastic energy. I'm just going to say it's 5. Okay. Later on, then, the cart moves along, and the cart gets up to the top of the track. At that point in time, there's no more elastic energy. The elastic's been released. We're told that it's frictionless, so we're going to say there's no friction, so there's no thermal energy. And we're going to have, but for sure it's still moving, and for sure it has some gravitational energy. I also know, like, when the cart's here, that's going to be moving faster than when it gets up to the top. So I'm going to say there's 2 bars of kinetic and 3 bars, 3 bars of gravitational energy. And how do I know it's 2 and 3? Well, I know that it has to add up to 5 because the energy has to be balanced on both sides of it. So there's my bar charts. Now I'm going to get my conservation equation. So this is EEL is on that side. And then on this side of the equation, it's EK plus EG. There we go. And if we had some numbers and things to calculate, we could do some other things. But this is our energy conservation equation. Okay. Next question. Very similar. It's still frictionless. The system has the cart, the earth, the track, but not the spring. So we'll go cart, track, earth. Okay. So it's held against the spring. So there's no EK. There's no gravity. This is the baseline. And is there any spring energy? No, there isn't. The spring is not in the system. There's our system, no spring, so there's nothing there either. However, when the cart gets to the top here, there's still no elastic, there's still no thermal, and we already know that when it's at this position, there's some EK and some EG. So on this side of the equation, we have EK plus EG. Of course, now that's a problem because we know, it's not a problem, but we know that the total energy on both sides has to be equal. So where did all this energy come from? It came from work. Well, it's a bad arrow. A bunch of work was put into the system. So there's our new conservation equation. Work equals EK plus EG. All right. The rest of the questions are very similar. If there's friction, probably means there's going to be some thermal energy. In these questions, you have to look at these things here. This means it's being lifted. This means the speed is 0. Speed is greater than 0. What else? Height, speed. So just kind of be careful with the information you're given. And you should have some success. You still might need some help. But if you do, just send me an email or chat with some of your colleagues. All right, good luck.